Hello, hello. Testing my microphone. Okay. All right. So, hello everybody. This is Junichiro Horikawa speaking. This is 10 p.m. in Japan time. I would like to start this week's tutorial live for Houdini. And this is the 59th episode for Houdini Algorithmic Live tutorial series, and the topic for today is to create the one you're looking at right now, which is this swirling like trail motion graphics using Vex and only Vex. Yeah, even I don't really use Solver for this one, so you can go back and forth using like a time slider or like these, so that you'll be able to prototype pretty quickly. I think it's rather easy to implement in terms of the algorithm itself. Doesn't have much things you need to do. It's just about combining bunch of random stuff, random values. Okay. Alright, so let's do this from scratch as always. And throughout the tutorial, I'm going to explain how I did it with some steps. Okay. So, first of all, what I have come up with is the idea how I will be able to implement this kind of motion graphics, like swirling, like a typhoon, like swirling trail. So let me first show how I thought about it. So what I wanted to do is to create, first starts from a simple point, then starting to swirl from that point, single point, and at some point it's rotating with a specific radius and a speed. Then go back to the center point at some point again. So it's mostly about the rotation. Rotation orbit like force, or it doesn't really is a force. It's just a rotational like process out there, together with some necessary information like properties like the radius. For each trail I have different radius, also a speed, and the length of the trail, and probably the thickness of the trail as well. So speed, radius, length, and thickness. And that's probably it. Then the speed can be considered as the angle as well. And I wanted all these processes to be done procedurally from the first frame to the end frame without using a solver, so that I'll be able to go back and forth pretty easily. So that's the criteria that I had, and let's see how I can do this. Okay, so let's see. Yeah, as Tom said, what if you were to add some rough edges to give it some texture thought? Yeah, you could do that, I think. Yeah. From the one that I have created, you could try out, and if you could show me that, that would be great. Yeah, in this tutorial, I'm not gonna go further than that, I think, since I don't have much time to do it. Or if I have time, I could also try that. Okay, so let's see. Going back. Alright, so let me start by creating a necessary information. First of all, I'm going to define how many points that I want, in which is going to be a number of trails that you want to use for the animation. Could be any number of points, could be 1, 2, 1,000 or anything. But as you can imagine, more points you have, more trails you have, you'll be able to run into a higher processing time. So I'm gonna stick with a lower number for this testing. So I'm going to first create a, oops, not this one, not here. I'm going to create a geometry node. Then first create a bunch of points in a single positions, meaning 0, 0, 0. Guess I could do, I'm gonna do a codeways attribute wrangle, using it as a detail, and I'm gonna define how many points that I want first. So num pt num or num pt is equal to num pt. By the way, I've just bought a new Mac Mini, which is a M1 processor. Seems to run Houdini just fine. Seems like much faster than my previous MacBook Pro, which still has some battery problem. Alright, let's set the maximum number for this parameter to be 100, and I'm gonna stop with the 20. Okay, now I'm just going to create 20 points on a 0, 0, 0 positions. So I'm gonna create a loop using this and pt. Okay, and let's create s point at point 0 set 0, 0, 0, so that you'll be able to have a single point at the center. It's a bit hard to see. Let me raise up the point resolutions. All right, so there's just there's 20 points in the center. Okay, it doesn't let me show. Where did it go? Where did it go? Okay, so 20 points. So let's call this init points. Now, first thing I would like to do is to set some parameters to this point, or maybe I can start animating this point, each of the point using a different values, the random values for the speed, radius, length, and the thickness already at this point. Since I am not going to use a solver this time, I'm going to animate this point based on the frame value, and then I'm going to use a node-like trail to create a line-like trail, a curve-like trail. Okay, so in between here, I'm going to create some animation using frame value. So I'm going to use a point wrangle. Good evening. And let's name this trail or swirling trail. So this is the main, this is actually a main node to do all the stuff, all the heavy stuff here. And after all of these, what I'm just going to do is to visualize what I have created as a line. But all of the calculation should be going to be done is going to be done inside this point solver, point wrangle, I mean. Okay, so let's do this. Okay, so I'm gonna open up the editor like these and try to start writing some code, which I'm gonna need it. Okay, so let's see. First of all, I'm going to create a simple like rotational value. So I'm going to start by creating a frame-based value, which is going to be from the first frame to the end frame. And it will be useful if I convert this value into a range of 0 to 1 for many purposes, for many reasons, like you can directly use it with the ramp parameters and so on. So I'm going to first convert this frame value as f and create a divisions which is from the current frame and divided by the end of frame, which I do most of the time in this series. Okay, now you get a value from 0 to 1. I'm gonna try to use this one to rotate and move this point. The next thing I would like to do is since I want this point starting from the center point and move up to some random radius and then start rotating, and at some point it goes back to the center point. So let's start by controlling the radius first. Okay, so first of all I'm going to set, for each of the point I'm going to set the radius for, which could be random, and then as a parameter I'm going to create a maximum radius first. Is trail I got a questions from Sword Chang. Is trail a solver? No, actually not. This is going to be done procedurally without using solver, just using this trail node with a point wrangle. That's it. So that you can go back and forth through a trail without resetting the solver. Okay, so let's see. What was it? What was I? So I have just created the maximum radius. Let's promote this one. And this is the maximum radius for the point to be able to use. So I'm going to set it something like 3 for now. Let's also set the range from 0 to 10. Okay, now next I am going to create a radius for each of the point. So I'm gonna name this maximum radius, and the current radius for the point is going to use the random based value in this case, because I would like to create a randomly scattered point. Okay, so let's do that. I am going to what's the best way? I'm going to create the random first. And let's also create some seed value. So float seed, random seed value, which is going to be using the ptnum multiplied by some custom value with some other random value as the seed. And probably it might be a good idea to add a parameter so that you can control the seed by yourself as well. Now try to enter this inside a rand parameter, and you'll be able to get a value, the random value in between 0 to 1 with this one. Now what I want is to multiply this by the maximum radius so that you'll be able to have a value in between 0 to maximum radius. Although I might not want to have a radius which is close to 1, close to 0. So I'm going to, instead of having a range between 0 to maximum radius, I'm going to use the fit 1, 0 to also set the minimum radius. So maybe I could have another parameter, float min rad is equal to chf min radius. Okay, and let's set the range from minimum radius to the maximum radius. Okay, I think which makes sense. So apply and promote. Okay, so currently it's from 0 to 3, but let's change this to 0.3 to 3. Let's set the C to some random values. Now I am going to try to move this point based on this radius. So let's do that. Now to do that, I am first going to, since I'm going to rotate this as well later using some another random values, I am going to move this in a specific direction for now. Let's see. I could first move this current point to a x direction. So I'm just going to update the x direction by this radius and see what happens. Now the point has been arrayed on a x-axis like these. Currently it doesn't really animate anything. It's just arrayed. And this is the a state position, a state radius for each of the point and middle of the frame, somewhere around right here on the timeline. And from the frame 1 to somewhere around here, it's going to each of the points will travel from the center point to those state positions. Then after that, somewhere around like 190 or something to the last frame, it's going back to the first frame. Okay, so to do that, based on a frame value, I'm going to create some curve, like using a ramp parameter to control the radius through time. Okay, so let's do that. Okay, to do that, I am going to update this radius using a ramp parameter. And actually to do that, I think it'll be, I think I need a this one to be ramped, this f value, the frame values to be ramped. So I'm going to create a attribute a variable called rad ramp or rad mult, and using the ramp parameter with name as rad ramp with f, and then multiply this rad mult value with the radius. Okay, let's promote this ramp parameter and see what I can do with it. So currently it's a straight line like this. So it is always similar to this f value. So if I play it, it will go from the starting point to the state positions from end at the start to end frame like this, which is okay if you just want to animate like the linear transitions from first to end. But actually what I want is more like a sine wave transitions. So let's try to create that kind of curve instead of this linear line. First I'm going to convert into a B-spline for each end so that it will be smoothed curve. Now I'm going to, now this y-axis indicates the point positions in terms of this radius. Okay, so if it's 0, it will be at 0, 0, 0 positions. If it's equal to 1, then it will be at the state positions. So I do need to have a state position for some range, and I do need to move this point slowly from the center and go to the state positions and go back to the center. So let's add more point control points for this one, like these. Create this kind of curve. It's also up to you what kind of curve you want to create. Let's do something like these. So from I still see some mountains here. So to have a flat face, I'm gonna create 2 more handle. Okay, let's see how it looks like. So starting from first frame, if I play it, first it comes from the center and goes to the state positions and go back to the center again, like these, back and forth. And you can check this out by going into any frame you want. Since this is not a solver, you can just check its positions interactively, and by changing this parameter you can also check at real time. Okay. Well, I still don't see any rotation here, so it's a bit hard to determine whether this mountain is a good curve or not. So let's try to add the rotation next. At this point, I'm gonna save this, and let's try to do another value here. I'm gonna move this seed value on top, which is because I'm gonna use it for many other purposes, right? So next, try to okay. So next, I was about to do the rotation, wasn't I? Okay. So to do the rotation, what I need to do is to create an angle for each point, and based on the frame, I have to define like how much the point should rotate. And to do that, first thing you might want to do is to determine like the maximum radius, a maximum like angle it can rotate. So let's try to create that first. Okay, so let's go to right here and let's set maximum angle. All right, and let's say that the value entered here will be multiplied by pi, which is equal to 180 degrees. Okay, so 1, if you input 1, then it means 180 degrees. Right now, let's try to set. Okay, I gotta promote this first. This one right here. Now let's set the range from 0 to 100. Okay, and I'm gonna stop by 20. Alright, now since I want to use the frame value as well in order to rotate, let's try to create a actual angle value in order to rotate each point. Now let's start without the random for now, so that each point will move at equal speed. Okay, so meaning float angle is equal to a maximum angle multiplied by pi multiplied by a frame-based value. So that is a f. Apply. Okay, and if I play it, no, I still have to rotate this point. So after I have created the angle, I am going to use I'm going to create a rotational matrix in order to rotate each point, using center point as the rotational axis point position. So math start with the identity matrix, then rotate this matrix to create a rotational matrix using this angle. And for now, I'm going to use this 0, 1, 0, which is the y directional value, as the rotational axis, so that it will rotate on top of this xz plane as a 2D rotation. Now, to rotate the point, you just need to multiply this point positions by the matrix. Okay, I think I got some errors. Let's see where. Row 8. Okay, spell mistake. Okay, still have some problem here. No, actually, I think it's looks on. Yeah, the trail has a problem. It doesn't matter about the trail for now. Just need a point. Okay, so let's see. So currently it's using the frame to rotate the point, and since it's 20 by pi, it's well, how much is it? 10 cycle. It's rotating 10 times. Well, 10 multiplied by 360 degrees. Okay, it looks pretty fast. Maybe I can slow it down for now, like 10. So that will be 5 cycle. Okay, but currently it's still looks too linear. So what I need to do now is to change its probably the speed and the starting angle for each point. Okay, so let's start by changing the starting point for this each of the point. So to do that, I would need to go back to this angle right here, and let's add additional angle value here, which is going to be used as a starting point from which angle it's going to start rotating. Could be a pi multiplied by 2 multiplied by some random based value, which will create a value in between 0 to 2 pi, which is going to be used as a starting angle. So let's see. The random seed could be any value. I'm going to use the seed that I have created right here and add some additional random custom numbers set by yourself so that it will be a different values with land this one. Okay, and apply. Now the point has been scattered with a different starting angle, and if I play it again, you start to see some base stuff already. Each point start from a different angle, which already looks like it's creating some swirling like motion. Now I'll apply it, and if I go back, if I go to this trail, and let's set the trail length to something like 20. Maybe that's too long. 5 or 10. You can already see that it's starting to create some trail points like this. Okay. We could connect all these points. There is an option to use this connect as polygon, but this doesn't work at some situations. For example, if you delete several points during the process, during the procedure process, so instead of using this connect as polygon, I'm going to use the add node to connect the points which shares the same attribute. Currently, no points have any attributes, so I'm going to add an attribute which can be shared with all the trail points, and let's name this as an ID. So I at id is equal to ptnum. So I'm just passing out the point number as an attribute to each of the point, and based on this ID, I'm going to connect all those points which shares the same ID. So apply, and if you look at the output of the trail by checking out the geometry spreadsheet, you can see that there are several points which shares the same ID like these, and which is equivalent to this trail points, each of the trail points. Now I can use this add node to connect all those points which shares the same ID by going into the polygon tab, by group, and by attribute, and then set ID like these. Okay, now if I play it, it already creates some interesting animation. Yeah, it looks good. Now in terms of speed, it's basically fine with these for myself. If you want to change each of the speed, by changing the speed, it will also change the length of each trail if you use this trail node. So if you want to try this out, you can do that by changing somewhere around here, or multiplying some value to this value here. So currently I'm setting the maximum angle constant for every every point. But if you change this maximum angle different for each point, then you could also change the maximum speed, the speed for each trail. I will show how it looks like. I'm just going to multiply some random values to this maximum angle, which I have created right here. So if I multiply the random based value seed plus some other constant value, you see that the length becomes different. And the speed of the trail is also different. Okay, which could be really one of the interesting stuff to do as well. Yeah. But for myself, let's keep this constant for now. I'm gonna go back to this later. Okay. Now next thing I would like to do is to control this speed from starting from this starting frame to where it goes to the state positions, then also when from the state positions to the center point. Now I would like to change the speed for during from start to state and state to start and during the state. I would like to set the speed where the point is at the state radius to be slower, and from first frame to where it reaches to the state radius, I would like the speed to be a bit faster. Also from the state positions to center, I want to make it faster. Okay. So that's what I would like to do. And in order to do that, I am going to use a ramp parameter to be able to control that kind of speed. So let's see how I can do that. In order to do that, I am going to modify this f value, which is currently from 0 to 1, from first frame to end frame, which is a linear value. But instead of making linear, I'm going to make it as again a sine wave-like curve. Or cosine-like wave. I could create some differences on the speed based on the frame. So I'm going to name this as angmult is equal to ch ramp. And I'm gonna name this ang ramp f and replace this f with ang mult. Okay, let's promote this value at here. Now currently it's a linear value, so it doesn't really make any changes, but the things that I want to do here is to try to create some curve so that from first frame to the somewhere around here it becomes faster in terms of the rotation, and then gets slower, then becomes faster again. To do that, the y-axis in this case will be used as the speed. X-axis it will be used as a timeline. So we can create another kind of curve. So if it goes straight up, it will go really fast. If it goes horizontal, it goes really slow. If I create something like these, you'll be able to see what I mean. Like, you can see that if I make it too flat, it will just stop at some point and then go back to the same point. Now I don't really want to stop it, but I want to slowly move the trail. So I do need some kind of gradient right here. Okay, so let's move this somewhere around here. Let's move this somewhere around here. What's good about this procedural process that while it's running the timeline, I can also move this parameter to check how it moves. That is great. Which I guess you could also do the similar things using a software like Touch Designer and so on, which I don't know how to use it. Alright. Now getting better. So at the first range, it quickly moves to the state positions and quickly go back to the center. And on the middle, it rotates slowly. Alright. Looks good. Now let's also increase the maximum angle to see the difference. Okay. Looking good. Now I might want to have a bit more trail length, so you could also go back to this trail node to increase this length a bit. This can be considered as a length ratio right here. Alright, looking good. Let's try to do a little bit more about this angle and see what I can do. Let me see. I am checking what I have wrote previously, if I done anything different. Because I think I think I have done something to make the lengths different for each of the line, but it is already different. When the radius is small, then the trail length is also small in this case. So I guess that makes sense because it's moving at the same speed. I mean the same angle. Not the same speed. Based on the radius, the speed is changing. Alright, so let's say that the speed is okay for now. What I want to do now is to change the axis or change this trail positions to be placed more three-dimensionally, because currently it's all flat. It's a bit boring, isn't it? So to make it a bit more interesting in terms of making more three-dimensional, I'm going to change this rotational axis that I'm using right here. By changing this one, let's say if I make it 0.2, you'll be able to change this rotational axis, and already you could make it three-dimensional. And you might have already imagined, by making this axis value random, you can make all the points rotating in using different axes makes it more dynamic and in terms of three-dimensional. So let's try to do that. But I do want to keep the feeling that it is using the y-axis as a main axis, but having a little bit of tilt in z and x axis. That will be more suitable for my trail animations. But you could always change that as well. But let's keep that rules. Use the y-axis as main axis, but also add some tilt to that axis angle. So to do that, I might need to create another random value. So let's see where I should do it. So first of all, let's combine these, then paragraph together, and let's create an axis. Currently it's 0, 1, 0, which is the constant value, and replace this with this one. This just creates a flat rotation. Though, what I really want is to create a random value. So instead of creating a constant value, I'm going to create a random vector value using another seed plus some constant number k. And currently if I use the random to create the vector values, it will be in between, all the x, y, z coordinate will be in between 0 to 1. Now I think I do want to have the negative value as well, and I also want this axis to be normalized as well. So I'm also going to subtract it by 0.5 for each x, y, and z, and also normalize the whole stuff so that the length of the axis will be equal to 1. Like this. Now everything becomes, the axis will become really randomish in this case, because the axis could be any kind of directional value in 3 dimensions. So you no longer see any like linearity or the directionality. It becomes totally 3-dimensional, which could be still interesting, but it's too randomish for me. Maybe if you add like more points, might be better, like 100. But if it's a bit too noisy, it's a bit too randomish. So I'm going to try to implement or trying to give a feeling of y-axis to this one, not just using the random value directly, but try to add some y-related value. So, and also it might be a good idea to control this y-axis value based on the frame, to control like maybe from the first frame to where the position state. It could be really randomish like this, but when it's inside the range of the state positions, then the axis will be more closer to the y-axis, and then go back to the more randomish 3-dimensional axis. That could be interesting. So to do that, let's see where I could change this parameter. Now I want to change this y value right here, so maybe I could add another value here, or maybe I can just change this value right here by adding some custom value, a custom parameter. So let's create another parameter, float maximum y-axis as a float number, maximum axis y-axis. Okay, and then add it to this one right here. So more value you have for this maximum y-axis, you'll be able to raise the y value relatively to the x and z. If you set this to 10, then if you normalize it, then you'll be having a lot of values affected with y direction. If it's 0, it's just going to be really randomish. So apply, and let's delete this one as well. And let's promote its y-axis value, which is this rango here. Apply. Okay, so currently it's 0, so it's so randomish. But if I raise, let's also set the range of this max axis from 0 to 10 and see how it looks like by raising this value up. If I raise this up, you see the y-axis starting to get more effective, and more value you have, more flat it goes, like these. Right, and somewhere around 2 might be good enough in order to have the y-axis feeling as well as some tiltness. And if I play it, looks good, isn't it? If I raise this up, it becomes more flat. If it becomes close to 0, it becomes more randomish. Like this. Right? I'm gonna keep it this to 2. Now, as I said, I will also like to control this maximum axis ratio based on the frame, just like I did for the radius and the angle. So let's try to add some ramp parameter again. Okay, so to do that, I am going to create another ramp-based value. Let's call this axis mult. Okay, it's equal to ch ramp axis ramp using f value again, and then I'm going to multiply this axis mult with this maximum axis. Okay. First of all, I'm going to promote, oops, I think I have some ch ramp float. Okay, I think forgot to axis, gotta do it right here, axis mult, apply, and also I need to promote the ramp parameter. Currently it's linearly increasing, so it's getting from 0 to 1, meaning at the first frame it is really randomish in terms of the axis, and then when it comes to the end frame, it's starting to get flatter and flatter in terms of y-axis. So let's check that out. Random to flat. Okay. That is not bad, but what I want to do is to make randomish and the first frame, and then becomes flat in the middle, somewhere around here, and then becomes randomish again. Okay, so to do that, what I need to do is to create a similar ramp parameter, which I have created right here. So first it's randomish because it's 0, then flattened, then becomes 0. So let's try to create similar mountain-like curve. In this case, I'm going to create like these. And it's also up to you what kind of curve you want to use. Doesn't really have to be like this, but dependent on what kind of motion you're looking for, you could try to change this curve as as you like. Okay, now let's see what happens if I play it. First of all, it becomes randomish and again flatter and becomes random again. Yeah, I could already see it. It becomes really interesting. And maybe I might want to add the minimum, like a multiplication or minimum axis value as well, because I might want to set the minimum to 5 as well, or to 1 as well. So, which I'm missing right now. So let's go back to add additional parameter float min y axis is equal to chy min y axis. Okay, then let's create a remapped value for this one right here. So I'm gonna say y axis value is equal to fit 0, 1, because the axis mult coming from the RAM parameters is in between the 0 to 1 in terms of range. Axis. Then I'm gonna fit it or remap this in between the minimum y-axis and maximum y-axis. Now I can replace this y-axis value with all these, which is more simple to look at. And let's promote this minimum axis value. Currently it's 0. Let's change the value coming on top of this max axis. And let's also set the range from 0 to 10. Now currently it's 0 to 2, so it's same as the previous one. But if I change this minimum value, minimum y-axis value, you can start by from the flat. And let's say if you want to make it starting from flat and then end to random, you can do like 5 to 0 and see what it looks like. Yeah, you could also do like these as well, which could be interesting. Yeah, I could see some story here, but for myself, I'm going to keep it like from, let's say, 0.5 to 2. Alright, good enough. Good enough for me. Okay, starting to get closer to what I wanted to have. Now at this point, I could try to visualize this as a polygon. I can add several more parameters to this one, several more steps to this curve right here, to this trail right here, but I would like to start visualizing a bit more as a polygon so that I can preserve my motivations to keep working with this one. Now the trail length might be a bit too short still, so let me try to increase this a little bit more. Currently the 15. I'm checking the parameter differences from what I have made with my sample. Okay, my sample I had a more longer length, so checking which stuff is controlling its length. I think it's based on the radius and the angle, the maximum angle value, which looks pretty much the same here. Yeah, looks pretty much the same here. Well, if I want to just increase the trail, I can open up this one and then just move this a little bit down and move this a little bit up. Oops. So that the length becomes a bit more longer. Okay, let's try to create a thickened trail out of this line. Now, the easiest way I could think of is to use either wireframe or polywire. Though what I want is to have a end cap for this trail, like this circle, this sphere. But if I use this wire, then I have bunch of like disconnected primitive created like these, which I don't really want. I want the connected polygon geometry, and I also want to control the thickness based on the point positions on a curve. So instead of using a wire, I am going to use the polywire. Now the problem with this polywire is that it doesn't have an option to create a round cap like this one. So what I tried out myself is to create my own like implementation to create a round cap from this straight capped a polywire pipe. So let's see how I can do that. But first thing first, I want to control the thickness of this curve, and maybe could be randomish as well based on each point. Doesn't really have to be based on the point position, but could be the thickness could be really random. So I also would like to set that attribute inside this swirling point. So in order to access to the thickness, I am going to create a attribute called p-scale and enter it right here in the wire radius. If I enter p-scale, currently I don't have any p-scale attributes, so it just disappear. So let's try to create that inside this swirling point code. Oops, what did I do? Just trying to open. Okay, doesn't let me open up. Let me see. Oh, wait a minute. Okay. Sorry, it was caps locked. Okay, so let me save this up. To add a p-scale value, it could be done anywhere inside the code. It's independent stuff. It doesn't really relate it to the movement, so it could be done anywhere. But let's see how I can relate this p-scale based on the value that I already have right here. And probably the thickness of the pipe could be related to the radius of the point, which is this one, which is controlled using this ramp parameter, going from 0 to the maximum, then go back to 0. I would like to do the same things for the thickness, so I'm going to use this same ramp parameter or ramp value in order to control the thickness, the movement of the animated thickness. Though I'd still need to set the maximum thickness and probably the minimum thickness. So let's first add this parameter. Float min thickness is equal to chf min thickness, and float max thickness is equal to chf max thickness. Apply, promote. Let's start by some small value. Okay, so let's say the minimum thickness is like 0.03, and the maximum thickness could be 0.3, which is used as a radius for the pipe shape. Okay, and then I'm going to create a random value, a random thickness for each point. So let's do that somewhere around here. So float thickness is equal to a random seed plus some custom value, custom random value. And this is in between 0 to 1, so I'm going to fit this, remap this using fit01 to a minimum thickness and maximum thickness. Min thickness was it? Okay. Apply. And one thing I was forgetting to do is to use this ramp parameter, which is for the radius ramp. So what I could do, I could create the, maybe I could use this fit10 again, or ch ramp for this random value right here with the same a ramp parameter that I have right here. Or I can just multiply this red mult, which I have already ramped this f value. So instead of doing like this, I could just multiply this by rad mult. I think that's probably fine. Okay, now that I have created this thickness value, I want to set this as an p-scale attribute. So f at p-scale is equal to thickness. Okay, now I see these thickness being applied to each of the point, and it's being used for each trail line. It's a bit too square, so let's also add some divisions. I'm gonna raise up the divisions to 10 to make it smooth enough. Okay, if I raise this up too much, then it's going to be slow, so gotta be careful. Now, currently, it's starting to look like more like a trail if I play it. You can see that, and from the first frame to somewhere when it becomes the state position, the thickness also goes from 0 to the maximum, which is cool. Same for the end, which is okay, but it is still too like pipe-ish, too flat on the end, which is not that good. And I probably want to control the thickness based on the curve. Maybe the head of the trail could be thicker, the tail of the trail could be thinner. So maybe I want to control that as well. Let's do that first. So to do that, I'm going to close this for now. And the easy way I could think of is to, first of all, go back to the add node where I was creating this curve. And let's check how many points are there. Now currently, based on the angle, the number of points differs, which might be okay. If the length is too small, then it will add more resolutions. But instead, I'm going to make a resample to have a constant divisions for each curve, and at the same time, I'm going to promote the parameter called curveU, which will create the parameter for each line for each point which is on the curve. You will be able to create a value in between 0 to 1 from start point to the end point. So 0, 0.1, 0.2, and 1 at the end. Okay, so let's do this. And for the resample length, start in the 0.1. I guess it's fine. Maybe 0.15. At the last, I'm going to also subdivide the geometry to make it smoother, so I can make it lower value. Okay, looks okay. And let's check the geometry parameter, geometry spreadsheet to check the curve view if I have correctly. So I have the volume between 0 to 1, and for each line, for each trail curve. And I'm gonna use this to define the p-scale, like p-scale scaling. So let's do that. I'm going to create another point wrangle. After this resampled, and p-scale, control p-scale. If you just want to make the linear scaling from the minimum to the maximum, you could, I'll say, first you can access to the curve u value for each point, which is in between 0 to 1. So I'm going to multiply this by p-scale. Okay, and as a result, you'll be able to have this tail to head like a hone-like shape trail. Now it's moving the other way, so I'm going to subdivide by 1, subtract by 1, so that it's rotating as I want. Okay, if you need more control, like if you want to have more thickness for the end, then you might want to add some additional parameters like float, min, scale. And then instead of using just multiplying as it is, you could use a fit 0, 1, and then the maximum could be a 1, and the minimum could be this min scale. Min scale. And I could raise this value up like 0.2 to have a bit more thickness at the end, at the tail. And if you don't want to have linear like scaling, you could also add like a ramp parameter for this F curve as well. Just like you did for other movement, like CH ramp, a scale ramp for the curve U. Let's promote this one. So currently it's linear scaling, but if you want to go, if you want to have the first half of the trail to have more thinner line and becomes quickly thicker, then what you could do is to create this kind of curve, or this kind of curve. So it's up to you if you want to have more control over the thickness. It's not really important here. It's just a matter of visual like preference. You could make the last one to be a bit more thinner. This one is the last one. It's a bit kind of hard to control. Like these, like a fish. If you look at it as a fish. Alright, but for myself, I'm gonna keep it as a straight. I think it's just fine. Now, what I want to do next is, still I do have some problem with this one because this is the face and the tail is too flat. I want to make it sphere-like. So let's try to fix that as well. And that one, it's going to be a bit more procedural modeling like stuff. And what I'm going to do. So let's see how I'm going to try to deal with these. The process that I'm going to do is to first retrieve these faces off this polytube, polywire. Then I'm going to remesh this to have a bunch of triangles, a bunch of points on top of this face. Then based on the point position and using the center position, I can calculate the distance, and I already know the maximum radius of these circle right here. So based on those information, I could convert the distance from the center to each point and use the ratio between the center point to the radius. I could convert the distance value into a angle, then use that angle to recreate a sphere-like positions using a trigonometry. Yeah, let's see how we could do that. So let's see how we can do that. And in order to do that, first thing what I would like to do is to let's see what I did. Okay, so what did I do first? The first thing I would like to do is to check which place, which plane, which face is at the end for this one and this one. And you could check that by checking the centroid for each face and compare it with the curve that you have somewhere around here, around resample. So you can see that the end point of the curve is at the center of this end face. Right here. If you retrieve the center point positions for each face, and compare it with this curve, and if that centroid point is on top of this curve, then that face is at the end of this trail, either the starting point or the end point. So let's try to do that. I'm going to create in this case, a primitive wrangle, because I'm looking at each faces to check whether it's on top of this curve or not. So primitive wrangle. Connect this curve to the second input as a guide. And then check info. Okay, first thing first. The center point position for the primitive centroid point position is at P. Right? Now, I am going to check whether this point positions is on top of this curve or not. Okay, so to do that, I'm going to first get the minimum point positions and to the curve with this one. Okay, I have a comment. Maybe you can group that pins spacing on num of polygons. How do I do that? Pins have 10 sides. Maybe you can group that pin basing on num of polygons. Other prim has 4 sides. Ah, okay. Right. You're right. That might be easier. So you're saying that this polygon has a 10 side, the other one has a 4 side. Yeah, that's much clever. Let's do that way. So yeah, instead of doing like these, I'm going to check the point numbers. First, I'm going to retrieve the primitive points. Prim points for each primitive. Okay, and then checking the length. If the length of the PTS is more than 4 in this case, then it should be these end faces. Alright, that's much clever. Thank you. And so for those faces, I'm going to set the group, set prim group as an end, prim num, like these. Okay, so let's check that out. I'm gonna use the delete node to check if the end, the end faces has been trimmed, so I think the group has set correctly. Alright. Now, as an additional information to those faces, I would like to set a center point positions. So, as a parameter, so v at cen is equal to at p, which I don't really need to, might not really need to do, but I do need it to, I did need to create an additional attribute like these because I want to preserve this after I have remeshed the polygon. Okay, oh, wait, the sweep sop has a group ends function, really? Okay, I haven't tried the sweep one. Let's try that as well. Sweep end cap. Oh yeah, does it create a hemisphere ending cap? Let's see. How do I use this? So the backbone curves and the cross sections. So the curve come here, circle, polygon. Okay, gotta set the scale. I'm gonna do it this later. Okay, and then set this single polygon. Ah, right. This is easier. Somehow it's flipped. Maybe it's because of this circle. Let me flip this circle. Okay, this is easier. Thank you for that. Okay, it's getting simpler and simpler. That's good. Okay, so this already has this end cap, which is good. Let's check. All right. I'm gonna rename this to end. And I also would like to set, I still need the center like attributes, center point positions attribute to each of the end cap. So I'm going to just delete those line and just going to set v at cen is equal to at p. Center pos. And probably I just need to do it for the end cap. Alright, this is much easier. I'm gonna delete these. Okay, so now I have enough information to try to create the hemisphere a ending. So let's do that. What I'm gonna do is to use the remesh node first, only applying for these end faces, which is going to be the end cap, and as an adaptive, so that I don't lose the edge that much. Let's set the group. Alright. And if you want to have more like resolutions to this one, you can change this relative density. Maybe raise this up a little bit. But I'm gonna keep with 2.5 for now. If you want to raise up the resolutions, you can always raise up the resolution of the circle as well, like these. Okay, I'm gonna keep it as, what was it, 12? Okay, now after I've created this remeshed value, I would like to check if the centroid attribute is being preserved, which is these one, and yeah, I can see that this value has been preserved, and I do need these in order to calculate the distance from the center point to each of the point for each faces. Alright, so now I am going to make all these trimmed out, make it like a flattened, unwelded where it's connected at the end right here. I'm not sure if it's already unwelded. Let me check. I'm gonna move this face. No, it's actually connected. So I'm gonna separate these faces from these two side face. So I'm going to use the facet node. And then let's use the cusp polygon. Make this large enough. Maybe 60 is fine, because the angle right here is 90 degrees. And then let's check if it's already been cusped. Okay, it's good. Now, here is some implementation, and first thing first, I would need to set the attribute, the normal directional attributes, where the point should move each of those points. I think, yeah. So let's check the normal direction. If I place this, if I create a normal node for a point, okay, I think it's fine. All those points which is on this face is facing perpendicular to this face. So I think that's good. Yeah, I think that's good. Now, after having these, now's the time to change this point positions so that it could create a hemisphere shape using the normal direction and the radius and the distance from the center point to the edge. To the edge of the vertices. Okay, so I have to do that, point wrangle, and I have realized that I need to work on the point which is on inside this end cap. I could create another endpoint group for that, or maybe I can just refer to the primitive group. So first of all, I'm going to refer to the connected primitive for each of the point by retrieving the first primitive value, first primitive number first, by accessing to the point prims 0 ptnum 0. All the points should be connected to one of the primitives, so I think this one should be just fine. And then from this primitive number, I'm going to check if this primitives is end cap or not. So if in prim group 0 end for prim is equal to 1, then that is the primitive that I want to modify. That is the point that I want to modify. Alright, now I want to define the how much I want to move for those points. And for those, it's a bit of geometrical calculations using trigonometry. So let's see how I can do that with a sketch. Okay, so currently I have a bunch of points. Top of this curve, okay. And thing is that I have the center point right here. And what I have as an information right now is this. First of all, the radius of this pipe, which is defined as a p scale, I think, isn't it? Yeah. Okay, and also you have this distance for each vertices. Okay, and then what else? You have the normal directional informations, in which direction the point should move. So what I want to do here is to change this d value, which is the distance from the center, as an angle. Then looking from the side view, I want to move the point upward to create a sphere-like shape based on this angle value right here. So somehow I want to convert this d value to an angle and use it for maybe this angle right here to move this upward so that I can have this kind of hemisphere value. Okay, so let's see how I can do that. Okay, so first thing first, I need to have this distance. So let's see, I have got this distance value, right? Okay, now what I would like to do from here, I also have this radius value right here. So with these, I can calculate first of all, the ratio from this d and r. So I'm gonna call the ratio as t is d divided by r. Okay. Now, and what I could do, I could make this, split it in this to 90 degrees, and then convert this d value into a value in between 0 to 90 degrees. So if d is equal to 1, then the angle is equal to 0. If d is equal to 0, then the value is equal to 90 degrees. If d divided by r is 0.5, then I want to have a 45 degrees, and so on. So to do that, I could create an angle which is equal to a pi, which is 90 degrees, multiplied by r d, which is, in this case, if d is equal to 0, then pi is also equal to 0. So that's the other way around. If you want to do the other way around, you could say 1 dx. I don't know which one's better because it depends on the orientation, I mean the rotation, I think. Okay, I have a comment. What about create a simple sphere in the centroid of a pin? Yeah, I think that's the easiest way to do it. But it's just my personal preference that I wanted to have like smoothness connections. Like if you just place the spheres on the end, the the edge right here is not connecting smoothly, so I didn't really like that. So that's kind of a reason why I'm trying to create like the smooth connection this way. If that makes sense. You see that I think it's pretty easy to just copy the points on the P scale at the end by checking the resample node. Let's check this one has the P scale. Yeah, it has. So just gonna quickly do what you meant, like making it polygon like these. You could easily move the sphere like these, but I tried it first previously, but I didn't really like this, like these connection right here, which might be okay if I just like render it with the matte surface. Might not be visible that much, but just my geometrical exercise, I wanted to make it smooth. So yeah, if you want to have a quick solution, I think this is a way to go. But I'm doing the a bit more hardcore way, I guess. All right, so let me continue. And I do like this kind of a mathematical like operation. Okay, so now that I have this angle value, I now have this theta. Maybe I can call this theta. Then from this theta value, I could get the height of this one. To do that, I also need to get the x value as well, right? So, because it's different from the distance. So I'm also changing the distance from the center as well. So I'm going to set the new x directional value as an x and the height as an h. Now the x could be calculated by since this is the radius and I already have this theta, you can calculate it by I'll multiply by cosine theta, and that is the x value. For the h value, you could calculate it by r multiplied by sine theta. And that's it. And as a result, you'll be able to get this point information. And that's the point you want to move from this point to this point. I hope it makes sense. All right, so let's try to implement that. All right, so okay, extrude with bevels on it. Never tried that. Okay, I will try that later. If that's easy enough, then I think that's the way to go. Okay, so, but first, let me try it this way. And so, first of all, I would like to get the distance from each of the point to the center, and the center point can be retrieved from the primitive, so prim 0 center at prim, and the distance is the distance between the current point positions and the at P and what was it? Center. Yeah. Okay, and also we need to get the radius, and do we have the radius? I do need to have the P scale at each point. I'm not sure if I have that. Nope. So I think I need to promote it, transfer it from somewhere. So let's see where I should do that. Okay, let me check. Let me check where I should do it. Probably I should do it when I was creating a poly extrude. Where was that? This one. Okay, this one. So previously I was using a poly wires, so I had a option to pass the attributes. I'm not sure if this one has. Okay, seems like it does. From backbone curve, yes, I do wanna include this p scale. Okay, so now I should be able to have p scale. That's good. That is good. All right, going back. And this p scale is the radius at each point. Okay. So going back here. Now I'm going to get the radius as a p scale. So f at p scale. Okay, now I'm going to calculate the ratio. D divided by r. D divided by r. And multiply by a pi 90 degrees, so pi multiplied by 0.5. All right. So that will be the angle. Maybe I just call this angle. Okay. Now I can calculate the x direction, x value and the h value. So float x is equal to, what was it, cosine r multiplied by cosine angle, and the height is h r multiplied by sine angle. All right, now's the time to place the each of the point position to the correct positions. Okay, so first of all, using x, you want to stop from the center point position. So vector new position is equal to starting from the center, and then use a direction from center to the vertex. So I might also need the directional value. Vector direction is a normalized direction going from the center to the current point position. So at p minus center. Then direction multiplied by x. So that is the x direction first. If you check, okay, did it change? Oh no, I also need to update the point position. So at p is equal to new pos. Oops. Okay, something went wrong. I think. Let's check. Let's see where I did do wrong. Okay. Let me see. So first of all, x direction should be fine. Yep. And the I think I gotta check if this p scale is correct or not, transferring from the sweep. So let me check that out. I'm going to delete only the cap. Okay, I think I'm seeing some cache here. And let me check the p scale value for each of the points by showing up. P scale, scale. Okay, so it says 0.22. Okay, seems correct. Okay, does not seems wrong. Let me also try placing sphere onto those points and check the size wise it's correct or not. Yeah, I think it's fine. So I think in terms of the code, something must be wrong. Let me check. I have this B scale and I have this radius D divided by R, which is the ratio. Yeah, I think that's also fine. What about this center? Center from the primitive. Do I have that? Let me check that. V at cen. Sorry for those debugging. It happens. Okay, so I do have these value retrieved. So I think that's fine. Alright, so that should be fine. And then I have, wait a minute, maybe this one might needs to be sine value. Since, wait, let me going back to the sketch. Okay, so the angle that I was creating is this value, not this one. So in that case, I have to flip the cosine and sine. Okay, so that's the part that I did wrong. So this has to be sine, and this has to be cosine. Alright, now the point has been placed, and I also need to move in the normal direction. So plus at normal direction multiplied by height. And how's that? I have just created a hemisphere ending. Now the normal is a bit weird, so I'm gonna fix it. Probably I need to fuse this as well, but looks good. And if I raise up the resolutions a bit more by raising this circle up, looks pretty nice, isn't it? Okay, sorry, I have many comments. Can you explain more about do the vector sen prim sen prim? I'm not good in vex. Also, it depends on okay. So okay, let me explain. So you were talking about this one, right? So this one is, first of all, I got the primitive number for each point, which belongs to the belongs to the point. The primitive number belongs to the point, and then I'm checking whether that primitive is at the end. Then from that primitive, I have previously created this center attribute to the end cap, where I did right here, this one. So only at the end cap I had this center point positions, which is this center point for this end cap right here, right? And then after I have remeshed, the center attribute has been preserved for each of the splitted mesh. Okay, meshed. I mean, then when it comes to here, for each point where it belongs to the end cap, you can access to that centroid attribute, which is always this center point at the end, and then using as a center point for this guy can calculate the radius from the center to each of the point by calculating the distance, like this one. Then the rest of the stuff is as I said. Just use it for the calculations. And checking what it looks like. It all looks great. Now I do see one problem here. I'm losing the trail like size going from small to big. Okay, let's see why is that. Is it because of the sweep? I'm not sure. Let's see. Previously I think I had this from small to big P scale. Does this one loses its information? Looks like so. Huh. I'm not really sure. I haven't really used this sweep myself, so I'm not sure if that's the reason or not. If anybody have any info about that. UV scale, UV seam, output. Does it creates? Let me try with the poly wire and see if I can preserve the P scale. With this one, okay, at this point I don't really see it, so I think I have a problem somewhere around here. Wait a minute, did I delete it? I think I deleted the code that was controlling the P scale. Damn, that was the reason. So I'm gonna re-add it. So that's not the problem with the sweep, that's my problem, deleting the one that I was using. Okay, so where was I? Resampled. So I was controlling the P scale. P scale is equal to vegetable. Let's create the parameter float min scale. And then control dp scale by, or multiply it with a fit 01. I'm gonna pass using the ramp parameter because I'm gonna make it linear. So fit 01, accessing to the curve, u min the original P1 to min scale, and then raise this min scale up to somewhere around 0.2 and see what it looks like. All right, so goodbye polywire. All right, then going back to the last node. Yeah, it looks great. All right, so this one is still like unwelded, so I would like to weld it using fuse, which could be heavy, but I guess that's fine. And now it looks more natural but heavy. Let's reduce the resolutions for this one to 10. Okay, still a bit heavy. Well, I'm gonna create a cache later on. And to make it a bit more smoother, I'm going to make it subdivided later. But for now, just checking how it looks like, as in terms of the geometry, looks fine, I think. Raising up the resolutions will make it really smooth hemisphere. Yeah, just like I want it. That is good. Now, at the end, I could add a subdivide node if you want to have more resolutions, have more smoother resolutions. Okay. All right, so in terms of the geometry, it looks good. Now, going back to the original curve that was a trail somewhere around here. Okay, let's see what else I could do here. So, okay, somehow, even though I'm at the curve, it's still slow for some reason. I might need to reopen the file. Let me try that. Reopening. Huh. Maybe it's due to opening many applications at the same time. Not sure. Can I just quit this Houdini once and reopen the application? See if it fixes. Since I'm using the Mac Mini, which I'm not sure is natively supported with Houdini, that's the things that I'm a bit having a fear of. Okay, I'm opening the Houdini right now. Okay. So, let's open up. Okay, smoother. So somehow it got being glitched for some reason. So I guess this runs smoother as well. That's good. Alright, now for the last part, what I would like to do as a touch up, let's see what else I did. An example. Let me check. So first, currently all the curve is starting to swirl at the same time, as you can see from the first frame, and also end at the same time. Now, to have a bit more randomness, to have more natural behavior, I might be able to shift when each of the point will start to swirl. By shifting its timing, maybe it's going to be a bit more organic and interesting. So let's also add that shifting attribute or parameters as well. Right? As a touch up. Because everything is moving at the same time. It's a bit too unnatural, and why am I having this value at the first frame? Alright, so let's see. Oh man, I think it's getting slower again somehow. Not sure why. I'm gonna do it above somewhere around here. Okay. Or maybe below the parameters, set of parameters. Okay, so I'm gonna create another parameter, creating a maximum start offset, how much offset I could use for as a starting for each point. And I'm also going to create a randomness to shift its starting frame, when to start it's swirling. So CHI. Okay, I don't speak is this Greek? Not sure. Okay, so offset frame or Russian, not sure. So maximum start offset that, and let's also create a randomness for each point again. So float start or int float start. A int start I could just say float start offset, which I'm gonna use the randomness at I do have a seed, and also let's add some value like these, which will create a value in between 0 to 1, and then I'm going to multiply it with a max start offset. Then you'll be able to have a value in between 0 to this offset frame. So let's have that promote the parameter, and I think I have some problem. I'm missing its equal. Okay. So let's set this to 50. So from 1 to 50, I could use it to offset the starting frame. And in order to offset the frame, what I could do is to modify this f value. So let's bring this down somewhere around here. And what I would like to do in order to offset the frame value, what I could do is to do the subtraction to the current frame with this start offset. Okay, and there is a chance that this value is going to be negative, so I want to keep this value maximum to 0. So I'm going to use the max 0. Okay, now do the same for the end frame. I mean the right here. So I'm going to subtract using the start offset. Now, as long as the frame end, which is this one, is more than 50, then I don't really need to use the maximum. If it's less than 50, then you might need to do it, but it's going to create a bit weird stuff. So the maximum start offset should always have to be less than this maximum frame end value. Now let's see what would happen with these value here. If I play it, looking from far away, you can see that each of the points start at a different frame. Makes it like, first of all, some points start to play, and then other points start to play as well, in between 0 to 50, and then end at the same time. Okay, so I do see some offset for the starting frame right here, which makes it more natural, I think. Now I do want to do the same thing for the end frame, so let's also create that value. Okay, so I am going to create another parameter, float max. Wait a minute, this can be int. Int max end offset is equal to chi offset. Wait a minute, I have named it ambiguous for this one, so, or I can just share the same value. So I'm just going to say max offset and use the same value for the starting frame and the end frame. So let's replace this with this one right here. All right, now let's also create the end frame offset value. So float end offset is equal to some other random value, so seed plus some other constant value, and then multiply by the max offset. Is this correct? I think so. Oops, nope. Alright, then in order to use this for the end frame, you just need to subtract this value for the end frame. So you just subtract this with end offset. And let's see what happens. Oops, I think I have a bit of problem here because I'm still seeing some swirling is left out at the end. So I think I need to fix that. Okay, let's see where that. Okay. The problem here is that I need to make this clamped in between 0 to 1. Since I'm making these values smaller, there is a chance that this whole equation becomes more than 1. Now that is creating these side effects, showing up the trail at the last end. So to be able to have the maximum value as 1 for this equation, I'm going to create the min function with 1. So if it's more than 1, then keep it as 1. Let's see. Now it becomes more natural. So each of the line also ends at the random end frame. Looking nice, isn't it? Alright. Okay, I have a question from DJ Multiple One. Have you got an experience in the simulations? I have a lot of questions. I am not that good at using Adobe simulations, so I don't have much experience compared to the procedural processes. I just use it occasionally based on the project, but I don't have much deeper understanding of it. Honestly speaking, I do want to use it though. Okay, so where was I? So now I think I have got it to the point where I really like its swirling shape. Yeah, looking good. And I think that's probably it in terms of the motion. Yeah. So let's go back to the geometry and check how it looks like. Okay. Looks good. Now, as a final touch, I might want to have like a little circle shown at the center when at the first frame and the end frame, based on the p-scale size of each trail. Okay, that's not really necessary to do, I think, but just a final touch. So shall we do that? So to do that, I am going to get that head point from each trail, which can be retrieved from this add node, I think, or I could just access to this swirl point, which is the head point. So at this point, I'm going to place the sphere when the point is at 0. Point is set at the 0, 0, 0 positions. Okay. So in that case, I think I need to create some conditions. Let's see what kind of conditions I need to say. So if the frame is if it's wait a minute. If well, let me just get the points at that point, that place. Okay, so let's see. So point. First of all, I'm going to try to copy 2 points, and at each of the point, I'm going to place this sphere, but only when the point is at 0, 0, 0 positions. Okay, change this to a polygon. Okay. Uniform scale to 2 and the frequency to something like 4. Now I'm also going to create a p scale when it is set at 0 positions. So let's also apply that attribute right back inside swirl point. So let's see. Oops. Let's see how I can do that. Okay, what is this error here? Okay, so let me check where I should do that. Okay, so if in this case I want to check if the f value. If f is equal to 0 or equal to 1, then that's the position where the point is at the center, 0, 0, 0. So if f is equal to 0 or f is equal to 1, then would like to set the point group as start ptnum as 1. Okay, apply. And let's go back and check the geometry spreadsheet. Okay, so I have a bunch of starting points. All right. Now I am still missing these p-scale value right here, which might be necessary in order to place the sphere with the radius. So let's see if I can also have that value. Currently, I think I have set the minimum scale, minimum thickness right here. Let's see if it's being used. The thickness is being used with random. All right. And it's being used. I see. This rad multiplication, which is in between 0 to 1, is causing the whole. It's causing to start from 0 as a p-scale. So let me change this value a little bit. So I'm going to make this as thickness mult and fit 0, 1 red mult, which is in between 0.5, or I can parameterize this, a min thickness scale to 1. And replace this value with this one right here. Okay, I think I have some error somewhere. Where's that? Fit01. Red mult. I am missing this parenthesis. Alright, now promote this main thickness. I'm going to make it 0.5 so that initially you have a little bit of thickness like these. If you look up this right here, you have it has the maximum on the right and it's a minimum on the left, so you have a bit weird shape going on in the first frame, which I don't really like. So that's kind of a reason I'm going to cover it up with this sphere in the first frame. And just going to go over, and it's what I want to do is to disappear or delete those sphere as soon as it starts to move. So to do that, I'm going to set the target points to set, or source points. Nope. Still don't have this group yet, which I thought I set it. Okay. Going back to the first frame, the target to start. So only the point with the start group will have this sphere. Okay, now everything is set. You can now add those two geometry together like these. Probably it might be a good idea to keep the resolution of this sphere and this trail a bit similar. So make it somewhere around 2. Then if you want, you can subdivide to finalize. Now let's move back and see what it looks like. Yeah, looking good. Starting from a single sphere, making a trail, going back to create a sphere again. Alright, starting to look good. Now I'm gonna go back to the visualizing step. I'm just going to colorize and make it flat color like 2D just by deleting all the light. By checking this disable lighting, we'll be able to create a flat shaded, which in this case I liked its visuals. So currently there's no colors applied, so let's also apply some color value, and I'm going to finalize this. Right, so where should I set the colors? I am going to set the color somewhere around here. I'm going to create a gradational color. I'm going to create a random color for each trail, and also I'm also going to gradually change the color from the first frame to the end frame. Like at the first frame, every trail starts from, let's say, red, and then all the trails starts to have its own color, own random color, and then fade out, becoming all the trails to be blue. So you have two kinds of controls over the colors. Alright, so point triangle color Now, in order to set the color, I think I need to have an additional attribute to use it as to use it for the color. And for that, I think I could access to the ID of each trail, which I'm not sure if it's possible to retrieve. Yeah, there's an ID. So this ID indicates the uniqueness of the trail. So I'm going to use that to change its color based on the ID. So for each point, oh, to do that, I might need to do something different. Currently, where does this ID implement? It's on the point, not on the primitive. Okay, I think there might be a problem using a point ID, but let's see. Okay, so first of all, I'm going to create some random values based on this ID. So float or does it have to be random? Let me see. I guess the color just be derived based on the ID, since the trail already is randomized for each values based on the trail implementation that I have created right here. So I'm just going to pass this ID as a color value. So float call is equal to add I at ID, and I gotta make this in between 0 to 1. So, and this, in order to do that, I need to have a total number of trail. Where do I get that? Do I get it somewhere around here? Nope. In order to get that, I think I can connect the initial points, this one, or I can copy this parameter. This is the number of points, and which is equal to the number of trail. So int numpt is equal to chi numpt, and then divided by float numpt, probably subtract by 1.0, so that you'll be able to have a range between 0 to 1. And paste, link that parameter. Okay, now I could use the color node to color the point based on the attribute using ID, no, not the ID, but color. And let's also make it from red to blue. And on the center, I'm gonna make it as white. Now I don't see much changes here, so I think I'm missing something. Let's see what. I didn't create the color attribute, so fcol is equal to col. Okay, so I have just set the color, but I do see a problem here at the end point. I see this red color. That is because when I do the remesh, the ID wasn't preserved for each point, unfortunately. So instead of having this ID as a point attribute, I'm going to set the ID as a primitive attribute. So I'm gonna pass this ID somewhere as a primitive. And let's see where is the good point to do that. If I go to the add node, no, maybe not this one. Let me see where it's the best point, best place to set the primitive ID. maybe after created the this sweep geometry, so which is somewhere around here. Okay, so at this point the primitive, oops, why did I do that? At this point the primitive doesn't really have its ID value, but the point has, so I'm going to promote it from point to primitive using attribute promote. The remesh cannot preserve the point attribute, but can preserve the primitive attribute. So that's kind of the reason I'm going to promote from point to primitive. Maybe I can also delete it. No, yeah, I can delete it, I guess. And then original name is ID. That will promote the ID value from the point to primitive. Let's check that out. All right, so I have these values. Now going back to the color. Now I can no longer access to the point ID, but instead I need to access to the primitive ID value. So int ID is equal to, first of all, get the primitive numbers from the point prims 0 at ptnum. The first one, this is the primitive number, just let's name this prim for the point, and then I can get the ID, which is prim 0 ID at prim, and replace this with the primitive ID. And then if I look at the color, then everything is set. Every trail has its own initial unique colors. Yeah, arrow daily looks good. I think for each loop will help. Yeah, I think so. For each loop could also do the job as well. The thing is that I wanted to make like as fast as possible. So using for each loop will significantly slow down the performance. So that's kind of a reason I didn't want to use it. Especially in this kind of animation stuff, I wanted to make it as much as possible to be efficient, performance efficient. But I think there's always a better way to do it. Yes, in terms of the easiness. Okay, so looks good. Now what I want to do now is to make the color fading from the red to these unique colors, then go to blue. And let's see how we can do that. I'm going back to the color node. All right, and I'm going to add additional like attribute. Okay, so to do that, I'm going to create the frame-based value again. So based on this frame, I'm going to create something like I don't know, maybe a linear value from 0 to 1. Then use that value to create a color gradational like values from red to blue. In this case, from 0 to 1. So let's do that aside. This one I'm going to create, first of all, create the f value again based on the frame value. So at frame divided by the float fend, which will create a 0 to 1 value from the first frame to the end frame. And what was it? Then if I just use this f value as a color value right here, what you get is this color gradation starting from the red to blue, like this, which is good. But what I want to do is to combine these two values, f and color. When the when the frame is somewhere in between the middle, I want to use the unique color, like these one. But at the end frame and the start frame and end frame, I want to use this gradient color. So to do that, what I am going to do is to use the loop. Okay, and then together with maybe a sine wave. Instead of using the ramp parameter in this case, I'm going to use this sine wave, like creating this kind of mountain, which is in between 0 to 180 degrees. So that is, so the first, I'm going to use this f value. And then the next target, the second target is going to be the ID based color, which is col, and then I'm going to use this pi multiplied by f. So the first frame 0, end frame 0, and the middle 1, like these. Oops, what did I do? Now let's see what happens. So starting from red, slowly becomes unique color, then go back to old blue, like this. Alright. Now I would like to keep the range of the red a bit more, so I'm gonna keep this one here, keep this right here. Okay, see what happens. Maybe a little bit more. Starting to get better. Alright, I think I like it. Now looking back at my sample code, it seems like I'm doing something different here. I'm not sure why. I'm using a cosine for the frame related value here. So let's try to see what happens here. So I'm gonna call this col1, and for the constant color gradient, I'm gonna name color2. And for that one, I'm gonna create a cosine based on the frame, and in this case multiply by pi. In this case, in this way, with these value, I'm creating the curve like these wavy mountain, going from 1 to -1. Okay, so this means that it will slowly change its color, and suddenly it becomes faster to change the colors, to have the unique colors, then goes to the end, slowly back to the 1. Okay, now that might make more sense. Okay, so in order to use this with this lerp, I need to make this value in between 0 to 1, so let's fit using fit11, which is used to remap the value which is in between -1 to 1, and remap this into 0 to 1, and then change this to color 2. Alright, now it starts from blue somehow. Maybe I should make this 1 to 0 if I want to start from red. Okay, if I play it. Okay, so visualize wise, it doesn't really make any changes, I think, but maybe a little bit, since it's just the difference between the linear curve or a sine wave. Just a little bit touch up. Okay. Looks starting to look good. Now I do want to change the color for these sphere as well. Currently the sphere doesn't have any colors, so let's also do that. And to do that, I think I need to set an color attribute. If I merge these together, yeah, it's not colored. So I think I need to set the color values to these as well. So let's think where is the best position to do that. Best place to do that. Let me think. I think this already has to have a color value. And maybe I could apply it a similar node like these to this one, which could be, okay, let me see. For these one, I think I can just use this gradient color value here. Okay, so I'm just going to copy this and point wrangle and call color 2, paste it. Do I need any parameters? Nope. And then at f at call is equal to call2. And that's probably should it. And I'm going to replace this color right here. And now everything is set. Looks good, isn't it? Now I can play out with all the parameters that I have set. Like if I change the axis to a bit more smaller value, I can create some more randomish axis rotation, which is already interesting. If you want to increase the number of points, you could always raise up right here. All right, makes it a bit slower for sure. And then you could also change radius. What's good about this is you can just change it interactively during the play out, I think. Okay, the minimum radius. Okay, the seed will change the randomness, random type, which is also interesting. Maximum angle, what was this about? It's 20 by pi. So if you make this smaller, you get a slower like movement. Okay, it's getting slower. And the length becomes smaller as well. If you make it really high, you get really fast. Now in this case, you might want to resample a bit more. Let's make this 20 back again. Alright. So I have this minimum thickness, maximum thickness. If you make the thickness really thick or make it all thin, still looks good. Yep, like it. Oops. I'm gonna make it from 0.3 to 0.03. Offset frame will determine how many offsets you want for each of the trails. Maybe I can set the range as 100. And if I set this to 100, each of the point will start at more random range. If you make it 0, all the points start to rotate at the same time, which is also fine. I'm gonna set it to 50 back again. The minimum thickness scale is determined how thick is the first point is. So if you make it 0, it becomes small enough that you cannot see its point. If you make it big, it starts from really big scale. Probably I'll keep it 2.5. Yeah. So, think I like it. Think I like the result. And finally, I'm going to make this smoothen out a little bit. And then cache it so that I can play out smoothly a bit more. I'll name this cache. Alright, that's good. Okay, I have a comments. It is the matter of for the odd purpose, maybe you can add a single thing backline above a thing, a main figures conforming the shape. For the odd purpose, maybe you can add a single thing backline. Yeah, I think that might create now some interesting graphics as well. That sounds good idea. Okay, if I play it, looks good. I kind of wanted to have these outline for these trail, which I think I need to use some shader technique to do that. So I didn't do this time. Maybe I'm gonna try next time. Get it into the shading with the Vex might be interesting for a PBR. Alright, so now I think everything is set. I'm going to gather all the parameters so that I can control in one place, and I'm going to finish this tutorial. Let's for bit linking. First of all, the number of points. The maximum radius, minimum radius, seed, maximum angle, minimum axis, maximum axis, minimum thickness, maximum thickness. Okay, I have a bunch of parameters to control minimum thickness scale. And what was it? I'm not sure if I can move this RAM parameter as well. Yup. And axis ramp. Okay, where else? Well, what's this about? This is the P scale. Mean thickness scale. Min scale. Okay, where else? Center positions, color. Okay, this one is already set. Okay, so that's probably it. Apply, accept. Okay, now I have all the parameters that I can control. I have a comment. I meant not outline, but line linear to center. Near the center of figures with the little offset. You mean... Not outline, but the center of the figure a little offset. Maybe get a single thing backline above main figures conforming the shape. You mean adding some like line on top of this figures as a backline? If that's what you mean. I don't know. If that's so, let me try that. Going back to the trail at maybe resampled curve, I can try to do that. I think I need to have the perpendicular direction. Do I get using the resample node? Let's see. Tangent U. Okay, I can use this tangent value. Okay. Okay. That's probably it. I think there was where was it? What was it called? To get the perpendicular direction. I think there was a node for that. Forgot. Frame, was it? Polyframe. Alright, so this will do the job. It's going downward, so I can flip it. Now, at each point, I think I have the P scale for these one. Yep. So based on the P scale, I know how much I should move this point. So let's try that out. Hey. Let's call this bone. And then based on the normal direction, could be a negative normal direction, and then together with the P scale, I can move this point with the gnome, multiply by some P scale, plus adding a little bit of offset. So let's parameterize these. Okay, just a little bit, like 0.01. Now let's also create some thickness to this line. For these one, I can use any kind of stuff. I'm just gonna use this poly wire. And then let me check what it looks like. Let's also normalize this. Okay, I think I'm gonna make it really thin, so being square is fine, I think. 0.01, or I can just copy this offset parameter for the thickness. Might be too thick, I don't know. And I could still make it triangle to have low res as possible. Alright, now I am going to bring this down somewhere around here and color it with black. it unshaded, and then merge it together and see how it looks like. Let's see. Actually, I need to use this one because I'm controlling the P scale. Okay, now this looks fine. Probably I could raise up the thickness a little bit more. Maybe that's too thick. Alright. Interesting. I'm not sure if this is what you wanted to see, but it looks interesting. Maybe a little bit off, a little bit less offset, or more offset. Oops, that's too big. Still big. Let's hide out the grid. Okay, yeah, like it. Like it. Maybe I can add this as a new parameter as well. Let's come here, here. Apply this parameter as a, I don't know, bone thickness. If you don't want to show it, you can just set this to 0 and so on. Like this. Alright, then let's subdivide this and save this to disk again. Okay, so that's probably it, what I wanted to show for this tutorial, and it becomes around 3 hours. Sorry for being so late. Thank you for watching as always, and all the comments, really appreciate it. I learned a new thing again today from you guys. Really appreciate it. I make it with the shaded view, looks like these. Yeah, maybe I want to do the renderings to make it a bit more prettier. Hopefully, if Houdini could implement like a similar like real-time rendering engine like Blender, that would be great, so that we could test it out inside of review. All right, now, so I am going to archive this tutorial as an archive video so that you can go back to this video page on YouTube to watch back what I did. I'm also going to upload the file and put the link to the project file to this video description page for this YouTube live video, so you can come back later to the same URL to download the file, check it for yourself. And yeah, I'm planning to do the other live tutorial next week at the same time as well, so if anybody is interested, I would love to have you always. And I'm so grateful to have all of you guys to with the comment. Really appreciate that. Okay, and I'm also doing a Patreon page myself. If you willing to support me for a little bit, it will be awesome as well. You could go to the page from the video description page of this YouTube as well. So if you're interested in supporting me, I'll really appreciate it. Okay, so that's it for today, and thank you very much Uh, and I'll see you next week as well. Okay, goodbye, good night, and see you next week.